This is lesson 4.1, prime factorization. There is only one way that 2 can be expressed as a product of whole numbers. The geoboard shows there is only one way that 2 squares can form a rectangle. This is actually a 1 by 2 rectangle. 1 by 2. Using your geoboard, make as many different rectangles as possible containing 3, 4, 5, 6, 7, 8, 9, and 10 squares. We're going to do just a couple here to save time, but we could start out with 4, for example. We could take this and make this a 2 by 2. You could see that clearly. We could also go down here and use 4 as a 1 by 4. So we actually have 2 rectangles that we can make from that. If we go down to this list of whole numbers, the numbers in the top list are the prime numbers. And you can see that you can only make 1 rectangle from those. The others are composite numbers. And if we go down here and just pick a couple examples, we already did 4. 4 can be 1 by 4 or 2 by 2. 6 can be 1 by 6 or a 2 by 3. 8 can be 1 by 8 or a 2 by 4, and so on. 9 can be 1 by 9 and 3 by 3, meaning that those are composite numbers because they have more than 2 factors. Determine whether each number is prime or composite. With 17, it only has 2 factors, 1 and 17, so it's prime. A prime number is defined as a number with exactly 2 factors. 12 is a composite number because it has 6 factors, 1, 2, 3, 4, 6, and 12, so it's composite. I would list factors of 12 like so, working in a systematic manner, and then go down and up. I like to call this a factor tower. Number, or letter A with 11. 11 has only 2 factors, 1 times 11, making it prime. 15 has 1 times 15 and 3 times 5, so it's composite. 24 has several factors, 1 times 24, 2 times 12, 3 times 8, 4 times 6, making it also a composite number. All whole numbers greater than 1 must be prime or composite. Every composite number can be written as a product of prime numbers. This product is the prime factorization of the number. You can use a factor tree to find prime factorization. The following 2 factor trees show the prime factorization of 60. And what they want you to note here is that whether I start with 6 times 10 or 12 times 5, if I do my prime factorization correctly, I will end up with the same prime factorization, 2 times 2 times 3 times 5, or 2 squared times 3 times 5. There is another method called the factored ladder, is what I call this. In the factor tree, you could choose any 2 factors. In the factor ladder or factor tower, you always choose the smallest prime number and continue to divide by that as many times as you can. Again, with the number 24, regardless of the method, we get the same prime factorization, 2 cubed times 3, or 2 times 2 times 2 times 3, regardless of the method we use. I prefer this method because it gives me my factors in order, and I can work systematically by dividing by the smallest prime numbers, starting with 2, then going to 3, and going to 5, and so on. I'll demonstrate a little later. Right here, as a matter of fact. If I take 18, I can divide that by 2. The result is 9. I can't divide by 2 again, so I divide by 3. 3 is a prime number, so my prime factorization of 18 is 2 times 3 times 3, or 2 times 3 squared. With 28, I'll use a factored tree. I'll start with 28. I'll do 4 times 7. 4 is a composite number, so I have to factor that. 7 is a prime number, so I can't factor that. 2 times 2 times 7 is my prime factorization, or 2 squared times 7. 16, divide by 2, get 8, divide by 2 again, get 4, divide by 2 again, get 2, 16, 2 to the 4th. Algebraic expressions like 6ab can also be factored as the product of prime numbers and variables. In this example, 6ab means 6 times 8 times b, so I factor the 6. I factor the ab. ab is obviously a times b. 6 is 2 times 3. So the prime factorization of the algebraic expression 6ab is 2 times 3 times 8 times b. So if we use 18 as an example, 18xy, we'll do the same thing here. We'll factor out the 18, and we'll factor out the xy. We factor xy into x times y. We'll use the raised dot here to avoid confusion. We're going to factor the 18 into 2 times 9, which means we have to factor the 9 again. 3 times 3. 2 times 3 times 3 times x times y would be the factorization or prime factorization of 18xy. Determine whether each number is prime or composite. 7 is a prime number because its only factors are 1 and 7. You can't divide it by 2 or 3 or 5. It is a prime number. We'll show you some tests a little later on to help you with that. Students should memorize prime numbers less than 100. It's really not that hard. 50 I can divide by 2. You get 25. I can divide by 5 and 5, easily making this a composite number. 67. Can't divide it by 2, can't divide it by 3, can't divide it by 5, can't divide it by 7, can't divide it by 11. It is actually a prime number. Its only factors are 1 and 67. Number 4, Louisa has 72 flowers to plant in rows in her flower bed. How many different ways can she plant the flowers? Justify your answers. What I would do there is I would simply list the factors of 72. She could have 1 row of 72. She could have 2 rows of 36. She could have 3 rows of 24. She could have 4 rows of 18. She could have 6 rows of 12. She could have 8 rows of 9. Quite a few different ways she can plant her flowers. Find the prime factorization of 34. I'll use a factor tree. 2 times 17 is the prime factorization of 34 because 17 is a prime number. 30, I'm going to use the factor tower here, or factor ladder. 2 times 15, 3 times 5. The prime factorization of 30 is 2 times 3 times 5. The prime factorization of 12 would be 2 times 6, which is 2 times 3. 2 times 2 times 3, or 2 squared times 3. Number 8, 10AC. I would factor that into 10 times AC, factor AC into A times C, factor 10 into 2 times 5. So my prime factorization of 10 AC is 2 times 5 times A times C. 16x squared would be 16 times x squared. Factor x squared into x times x. Factor 16 into 4 times 4. 4 is 2 times 2 times 2 times 2 times x times x. 2 times 2 times 2 times 2 times x times x. Seems a little silly. 2 to the 4th times x squared. I would leave x squared in its original form. I don't think I would factor that. 11g cubed would be 11 times g cubed. G cubed would be g squared times g, which would be g times g times g. 11 is a prime, so I simply leave it the way it is. My prime factorization of 11g squared is 11 times g times g times g. I believe we've done all of those already. Here's the vocabulary for this lesson: prime number, composite number, prime factorization, and factor tree. Students are to have those written in their notable and should memorize them for the Chapter 4 vocabulary test that they'll take towards the end of the chapter. At this point, you can quit the video, go back to my Moodle page, log in, take lesson quiz 4.1. Thank you very much.